Okay, this is in your blue note packet. I'm just going to give you the notes for inductive reasoning since you're at home. And then when you come back, we'll go through a bunch of examples. Okay, so you might want to pause it and look at that at first, but I'm going to start going through these. Okay, there's different kinds of number patterns here. In this case, it's a simple pattern. It's going up by the same number every time. It's adding 4. That is called an arithmetic sequence. Okay, and in this case it's going up by 4 every time, so it's really easy to tell what the next numbers are in that sequence. This is a geometric sequence because what's happening, and you guys are probably looking at that thinking I'm dividing by 2, but when we do geometric we always do it by multiplication. This is a geometric sequence, and instead of saying you're dividing by 2, it's multiply by 1/2. Okay, so all I'm doing is taking half of it every time. So this is going to be 25 and 12.5. Now, number 5 is also going to be geometric, so I'll let you guys figure out what the next terms are there. This sequence is a fractional sequence, which I'm sure you guys just love that. Everybody loves fractions. What you want to do, there's a couple different strategies for this. One would be to get a common denominator, or another strategy would be to change the fractions so they make a pattern. In this case, I can tell that this fraction doesn't fit with the rest of them because it's going 1/8, 2/7, and then there's this one, and then 4/5. So what I want to do is change this to something that fits the pattern, and 1/2 is the same as 3/6. Then I can tell that the top number, the numerator, is going up by 1 and the denominator is going down by 1. So I got 1, 2, 3, 4, 5, and 6 for the numerator, and then 8, 7, 6, 5, 4, and 3 for the denominator. And since I can simplify this, this would be equal to. You always want to simplify fractions if you can. So that's a fractional pattern. Okay, this one is really hard to pick up. Actually called a Fibonacci, and we will talk a lot about Fibonacci's because, believe it or not, there's a lot of things in nature that follow a Fibonacci sequence. This is also a Fibonacci down here. Okay, oops, Fibonacci. There's a lot of things in nature that follow a Fibonacci sequence, like the petals on a plant and things like that, but we're not going to worry about that right now. Here's how Fibonacci works. Like for instance, I'm going to look at this one and give you that one, and then you go back and do this. I look at that and it goes up by 1, and then it goes up by 1, then it goes up by 2, then it goes up by 3. Well, that doesn't make any sense. So here's what the pattern is. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So all I'm doing is adding the 2 previous terms together to get the next term. So to get this term, I go 8 plus 13 is 21. Then to get this term, I go 13 plus 21 is 34. This follows the exact same process. This one I'm going to let you guys figure out, but I'll give you a hint. You're going to figure out what happens between each pair. Like I add 4, add 9, figure that out, and then try to find a pattern with those numbers. And I also want you guys to draw the picture patterns here, and we'll go through them when you get back.